Good times. Happy to be here. Happy so many of you showed up for this adventure into fun stuff. Let's see if we can get a little bit of image coming out. Whoa. Hi, I'm STOK, or my name is Fredrik Alexandersson, but most people know me more about my hacker handle STOK. And this is my talk, Weaponizing Plain Text, ANSI Escape Sequences as a Forensic Nightmare. And when I was preparing for this talk, they said that it's extremely important that you create a slide that explains the whole table of concepts that is going to happen. So I figured that I could do that, but we're not. Because we got 280 slides to go through in really fast pace, and it's all going to be about this vulnerability class thingy that haven't been touched for ages. Fun! I used to travel the world and doing live hacking events and doing a lot of bug bounties and create educational videos on YouTube. But nowadays, I fight cybercrime at TrueSec. And one thing that I learned from doing shitloads of incident response is that log files seems to be a thing that's important to define your timelines. So I was curious, like I normally am, are log files important? Do anyone else than me think they are important? So I asked on this platform formerly known as Twitter a bunch of questions. And I got great answers coming back. And the short answer is yes. Log files are important because they are a vital component for maintaining application reliability, performance, and security. And it seems like the common idea is also that logs don't lie, but people do. And even though your logs maybe don't lie to you, do you still trust them? And what happens if you don't? Because imagine this scenario for a second, that you are the incident response lead at this global logistics company, and you're sound asleep in your bed, dreaming about boats or containers, whatever, if you're into Docker or something, right? And then suddenly you get this rude awakening from your manager that's pissed because you've been breached. So you are the incident response lead. So you'll spin up your incident response team. They work 24/7, those poor bastards. Starting to collect logs throughout all the systems, because one thing that I learned is that forensic people, they're very picky about their logs and they're greedy as hell with them. So they want all of them. So you as a professional person that's been storing your data offline, because you know log shipping is important, enter your big data app 4000 that manages everything. We have all the logs. Select the date and then choose to export data. That data you download to your computer. It's called everything.log. It's a massively beautiful log. And then, like most of us do, you're just going to make sure that shit's in there, right? So you start by catting it and looking what happens. First, you see a lot of data coming out, and you're happy and excited. But then suddenly in the middle of it, boom! You get an ad for a ransomware restore service? And they're even nice enough to provide you with a calculator so you can do the math, how much it's going to cost you to get it back. And that's kind of the situation where you're starting to realize that, shit. And the reason why this is happening is because of something as simple and amusingly fun called ANSI Escape Sequences. And for me, this whole thing started with this CV in Rails. And I'm just going to read this straight out of the thing so you understand what goes on here. So, affected versions of this package are vulnerable to arbitrary code injection. There is a possible shell escape sequence injection vulnerability in Raxlint and common logger components. Carefully crafted requests can cause shell escape sequences to be written to the terminal via Raxlint middleware and common logger middleware. These escape sequences can be leveraged to possibly execute commands in the victim's terminal.
Excuse me, it's you, tiny STOK. What do you mean possibly? Either you can or you cannot run arbitrary commands, right?
Well, you're actually right about that, giant STOK. Thank you for pitching in. But it kind of all depends on what terminal you're using. Because the arbitrary commands that are being run inside those log files requires you to interact with it using a terminal. And terminals comes in many different shapes and forms. It's implemented into applications like VS Code and Docker. Then you have iTerm and Kitty and other ones that are third-party. You got Windows Terminal, Terminal App, and GNOME VT that are bundled with your application. You got Putty and other things too. But then you got old stuff like Xterm, right? But we're also having terminals when we interact with the cloud because we're maybe doing a recovery situation or trying to connect to our VM in some way or form. And those are terminal emulators as well. And since I wasn't interested in the possibly part of this, I figured, how can we do this? But I had no idea where to begin. So like any kind of self-respectful security researcher, I Googled what are ANSI escape sequences because I had no idea. And I realized that people tend to really like to customize their terminals in many ways and forms by changing colors and just adding cool stuff. Especially if you're using software like Arch Linux, then you're into this stuff. And I also realized that in 1978, the Strand boys released their band, their epic record, We're Gonna Have Some Fun Tonight. And even though it was released the same year, the VT100, I don't think that what they thought would be a great time was to connect serial cables to this VAX computer in a data center and look at ANSI terminal stuff. Even though I would think that would be pretty cool. I mean, imagine that setup at home. And I also realized that ANSI escape sequences are the thing that are putting things on your screen, and you can do different stuff with it, like you can move your cursor around, or remap the keys of your keyboard, or you can even print stuff. Ding. But you can also create whole UIs with just using ANSI escape sequences. So everything here is just that. It's explaining positions and colors and shapes and forms. And the way to do that, you need something called control sequences. And these are vast and many. And Xterm is one of the terminals that kind of describes this, because we're not having cables anymore. We're using these over other protocols. So we need to emulate that kind of stuff. I didn't understand jack shit about this first time I saw it, so I thought, maybe you are savants, but I didn't understand, so I figured I'd break it down for you. So, when you look at the documentation, it says this: CSI PMM character attribute doesn't mean anything, but this is actually what it is. So it starts with, and the output is this. The result is going to change something to the color green. And the reason why this kind of works is because of this bad boy, the escape character. That's an invisible character. And it comes in many shapes and forms, because I realized after a while that all these things do the same stuff. So we have octal, hex, Unicode, decimal, whatever. And if you're doing some searches on GitHub for this, you're going to see all different kind of ways that people implement it depending on how things are getting parsed. And I realized that Bash prefers octal, Python likes hex, Java and JavaScript likes Unicode, and PowerShell like decimals. So with that said, the escape character is the one that we always need to start with. And that is it's an invisible character, so you can't see it. So the next one here is called the control sequence introducer. And that is, you can think about that as the way of telling something to perform a certain function. And what we do after there is that we're going to add a color. 32 in this case is green, and M means change the output color to said color code. So you set the string that you want to have green, and voila, it turns green, right? But you also need to terminate it in a certain way. So we'll do another escape character, another control sequence introducer, and then we do 0M, which means reset to the original kind of color output. Because otherwise, the continuous of the screen output is just going to be in green. Hot smash. And you need to terminate it in the end using a terminator, ST or bell character. And if you accidentally, like I commonly do, grep some kind of files that have binary stuff in them, and your terminal goes ding, 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 that is this being interpreted as a bell character. So I figured that's cool. But what happens if we take this printf command and we put that into something else and start to interact with it? Well, if you use Vim, it's just going to show you the representation of the escape sequence, which is cool. Same goes for Nano. And if you're looking at it using a browser, instead you're going to see the Unicode representation. We talked about that earlier. Sometimes it's the representation in hex and whenever. Browsers just seems to like putting it in Unicode. But if you use cat, for instance, it's going to render it and display the color. Same goes for grep. It goes for tail, awk, and even curl. Because if we put an escape sequence in the title here, it's going to render. And that's what I kind of realized, like, oh shit, you can put stuff in the title and it's going to render in curl? Fun! I wonder what happens if we put it in a text record? Could it fire there? I mean, wouldn't it be lovely to get those pesky incident responders and threat hunters to fire when they were doing a whois on your badass domain, right? We get a ping back that something is going on. Sadly, in OS X and its lookup, they beautifully escape this. You can see there's an extra slash in front of it. But on Windows, it doesn't. Sweet. Thanks, David, for letting me know that. And that, again, shows us how differently this is getting interpreted. So I'm starting to think, is this even a security issue? Or is it just me trying to do like a self-XXS situation where like, I can change my own color? Cool. So I needed to ask myself the question, like, where would this be an issue? Who would this be an issue for? And how would this be an issue? And what would be the consequences of this? Well, the obvious first one would be, where would this be? Log injection. Because in the CV, it mentioned that it was the common logger middleware. I'm like, okay, obviously log injection, cool. Who is it going to affect? Well, it's going to affect, at least in my humble opinion, it's going to be DevOps, sysadmins, incident response and forensic people, or kind of more or less like anyone that interacts with log files using a terminal. I do that all the time. I'm none of those. But I YAQ stuff and I play around with things. So I figured that, okay, how can I do this in a scientific way? Well, if we look at the OWASP part, it says that log injection vulnerabilities can occur when data enter an application from an untrusted source. So we need to put stuff there. The data is written into applications or system log file. Check, we need to do that. And for it to be successful, even though the standard describes how an XXS would work, I needed to adapt it a bit, so we changed it up. Injection of new bogus log events. We mean we're forging stuff using an injection. We need to verify that. We also need to verify that we have an injection of an escape sequence, hoping that it's going to be viewed inside a terminal emulator. And then finally, the injection of set commands that a terminal emulator then would execute. That's a good start, right? And I think the perfect test bench for this would, in my case, be Docker, because Docker, by design, kind of likes to put log files in standard out. It comes with a built-in terminal. It's very easy to set up, so I figured, okay, I'm going to run this getting started app on Docker desktop and see what happens. Because to interact with log files, you normally would use a terminal, and you would either attach to it, if it's not you're using Docker desktop, or you would do Docker logs or something else to see whatever goes on. Then I realized that, okay, I can't just take this printf command and put that in the browser. That's not going to work, so I need to URL encode it a bit. And for good measures, throw in a good line break there as well, because everybody knows a real vulnerability only exists if you're able to add a new line to it. So I put curl in, this URL encoded stuff, and fired it away. And I was kind of shocked with the results coming back, because there was nothing being showed in the response coming back, but I obviously was able to enter a new line. I was also able to actually change the color output of whatever was running in the Docker logs. So it's like instantly proof of concept. Because injection of new bogus lines, check, got that one. Injection of escape sequencer, yep, got that one too. And then finally, commands that a terminal emulator would execute. I'm not even using the terminal emulator. I'm using Docker that's rendering it for me. And the situation here is that we need to remember, even though this is just cool colors and all, we can't decide full UIs using ANSI escape sequences. So it's only the limit of the curious that's going to be what we're able to do here. So we confirmed that we were able to add some color in there. And I thought that was cool. But the Strand boys, they weren't too excited. Colors in log files, that's meh. So I needed to prove them a bit of impact, what's actually going on here. So I started to do some research, and I found out that H.D. Moore in 2003 found a really nifty way of actually manipulating terminals in a way that was really cool. And he used something called reporting of the title. And I'm going to show you real fast how it works. I use a Windows terminal here. So we'll start with something called here, you have the OSC sequence 2, and then you say, let's say owned, and it's going to be written to whatever terminal title you have. If you're using any kind of terminal today, you change the directory, and it shows up inside the bar, that's doing exactly the same thing. But that's cool and all. You can actually write stuff to the terminal's title. Cool-ish. But he realized that, looking at the standard, that you're actually able to do something called CSI 21T, which means reporting back whatever was written inside the terminal and getting that put on the command line. Now things started to look interesting. Because if you can write, let's say, this payload down here, and you can put that inside the title, and then use the reporting thing to request whatever is in the title, and put that on the command line with a bit of social engineering, people would press enter and shit's going to hit the fan. That's been fixed in 2003. So can't do much about that, right? So I started to Google a bit more, and then I found that Evil Alive, Jekyll and ASCII did a cool research paper on all these different web servers that had these ANSI escape injection sequences in them that rendered, but that got fixed too. And in 2022, EvilTerminal, sorry for trashing your name, found some research that he was able to create this, they were able to create this log sequence thing where if you write into the title, you would create a DOS situation. Cool. At least we're going somewhere. And I'm excited now. Like, maybe this is the first step against arbitrary command injection. But that's fixed too. So it's an epic fail at this moment. I'm like, am I going to be stuck here with just being able to add colors to stuff? So I did the final thing. I reached out to the regional reporter and said, how did you do it? How did you create this arbitrary command injection that's been mentioned? I really, really, really want to know. And he responded back that, yeah, I used this report from 2010. I didn't provide anything else. They just took the decision on their own. I'm like, crap, that's fixed. So nothing new. Everything I stumbled upon was just old fixed stuff. And speaking of old and fixed stuff, this is kind of what I looked in the 80s. I'm kidding. I'm not that cool. I'm probably more like this. And if you look at the angle at the arm here, you see, that's a very, very interesting thing because it's exactly the same angle that this gentleman in this band picture has. And he's one of the first people in Sweden that got to sell DS90s and Unix computers. But he's also my dad. So he made it possible for me to access computers at an early age. And I must say, I mean, that's a pretty fucking badass thing. But now standing here and looking at this picture, I'm starting to realize that maybe I'm looking a bit more like Lasse. That was on the same tour as my dad when he met my mom. Anyway, the standard is really complex. So when you dig into the standard, that didn't seem like it was enough for the terminal developer boys. No, they wanted more features. So they invented something called proprietary escape codes. And these proprietary escape codes are unique for the different terminals. Now they're starting to mix with each other and they're trying different things. But they can do cool stuff like adding notifications and just adding a more rich experience inside a terminal, like adding a twirly thingy or other stuff. But there also were some not genius moves like maybe we should allow an escape sequence to run a process with arguments. It seemed like a really bad idea. Just like a bad idea it is to run a Flash website somewhere. And it's just as rare because nobody uses that old terminal. So even though I had that cool proof of concept, it's like, yeah, it's not going to work. We need to have something that's going to be adapted, trusted, and used by everyone, and nice that we could weaponize. Because we are nothing but tricksy little hobbitses when it comes to doing security research. And one thing that I found that I thought was real cool was this one here, OSC 8. It's one of the newer ones, and it's widely adapted. And as you can see here, if you ever run PowerShell, that happens. I know it's a curse, but if you do that and you type it wrong, you'll get this error message with this link that you can click, and when you do that, eventually you will end up in a web page. And the reason why this works is because you can use OSC 8. So you'll start with this OSC 8, you'll put in whatever destination you want, the name that you want to be written there, and then you close it off again, and voila, here's a link. In the beginning, you were only allowed to use URI like HTTP and HTTPS. That was cool. But then some of the developers over at Microsoft thought it was cool, so why not use file as well? Because maybe we want to reference stuff. And that seems like a great idea until you realize that you can actually put CMD in there. Now it's starting to be an issue. But even if you can do just CMD, you can't add any parameters, but it's only a matter of time somebody's got to figure out to bypass that stuff. That's cool. And as you remember in the beginning, if you're not terminating this correctly, like the color green, right? It's all the output that you're going to have is one big freaking anchor that's going to be all over. So if you're using this in, let's say, VS Code here, and all the output is going to be one big link, but you also saw that there was a warning coming up. And some of these terminals, they have warnings in them. So I figured that's cool, but we needed a way to once again, not make this self. Is there any way for us to URL encode it? So I figured, let's see what happens if we send that into Docker, for instance. And you can see the whole output is just one big file, and one big link. And depending on what terminal you're using, it's going to be interpreted in different kind of ways. And it's not going to stop putting this link until you terminate the sequence. And depending on what kind of terminal you are, if you click stuff, it's going to do certain things. And obviously, you can just accidentally click stuff and voila, fun. And then somebody decided that text is only cool for mod players, so inline image support. It seems like something that we need to implement into our terminals. Great idea. So in the latest release of Windows Terminal, you now have support for something called Sixel, which is great. Now we can put images in there that are being rendered by just using ANSI escape sequences. And that is great if you have a bunch of different kind of log files that you would like to put stuff in. So I want a little bit of hand raise here. How many of us want us to actually see what's inside this log file? Can I get a hand? Okay, cool. Let's see what's in here. Not the image you thought it would be. But this is enough proof of concept. Imagine you're sitting there, you're going through your logs, and then suddenly, oh, tasty. Another one that we have is the OEC52. And if you ever used a shell and you connected to it and you wanted to copy-paste and that didn't work, it's been fixed because everybody using Tmux and OEC52, so you're able to copy between the shells and different paste of clipboard buffers. And we can use that. It's great because an escape sequence like this would say, well, if let's say that we have open calculator and a new line, we base64 that, and we run this command. What's going to happen if you do it in CSH, first you're not going to see anything. It just populates your clipboard buffer, and if you right-click or Control-V or whatever, it's going to put that on the command line. But CSH requires you to have user interaction. So you press enter here, oops, nice, fun. But if you put it in bash instead, a lot of different other stuff happens because that honors the new line. So if you just paste it, it's going to go smash, which is also good because depending on the kind of terminal you're using, results are going to vary. So I figured, okay, I wonder what happens if we do a little bit of sleep and some echo and who am I stuff, and we put that in there. So I did that, and then we pasted it inside Docker. It ran directly. Then I did it in VS Code. It required interaction, but it also had some warnings coming up, and that was cool. The local terminal app that just smashed it directly, no problem there. And eventually, Windows Terminal had this warning too. But what's really interesting about Windows Terminal and this warning is that if you have something, let's say 10 lines of code, and then you have the malicious payload, the pop-up that's going to come up is going to display 6 lines. So we can just do 7 lines, and it's going to be empty, because nobody's going to scroll down there, because everybody's busy, and they don't have time for shit, or you can put other stuff in top of it, and then eventually you're just going to smash. Fun. So that's a potential way to kind of social engineer bypass it, by adding just like new lines to do every basic support thing you had. But that got me thinking, okay, maybe we can create a polyglot here that would have an XSS payload, a SVG XSS payload. It's going to have like this kind of curl command that collects some user data and then talks to some external thing. Obviously here I'm sending it to localhost to make sure that, we're not leaking any information. And then I had this to work on Windows as well, because I wanted this to be like a polyglot thing. Basics4 encoded it, catted the bad log, and started to paste it inside different kind of systems. Obviously, you can see stuff there, and then sometimes it executes directly like here, and if you paste it inside a browser, it's going to pop an XSS for you, which is great. And at this collaborator, you're going to get some IDs coming back about the system that you're running, and this is perfect. It's a great way to just fingerprint whatever goes on, but it requires a user to interact with it. But that's not kind of the limitation. You can also do it in different ways. So in theory, you can have like a reverse shell being spawned or exfiltrating of files, whatever, and put that inside somebody that interacted files, terminals, clipboard without they knowing whatever happened. Fun. Until it's too late, though, because you smash it away and then, oh, shit. And one way we can do that and make sure they didn't know anything is to hide our tracks, or if you want to, mess things up. And we can do that by using different kind of escape sequences. One would be the H one, that means you move the cursor all the way up to the beginning of the screen, or you can clear the scrollback buffer, or you just erase the entire screen. And the result is going to be that if you put a lot of information on the screen and you run the H, it's going to clear the logs and go straight up to the beginning. So I figured, I wonder what happens if we paste that into the log file and get an error message coming up. Well, it's going to clear the log for you. Splendid. And then if you go back and forward between the terminal and log, whatever that get renders, it's going to clear the log for you. So it's going to be quite annoying for somebody that's trying to investigate something, because you're going to see half of it, then it's going to all gone. And remember, we can put whatever we wanted afterwards, so we can kind of hide our payload there. Another way to be really annoying is to create a denial of service attack or brick something. And since we're using codes that are built into the system, these are things that everybody trusted, it can be real fun. Let's say print screen, for instance. That's great. Why not being able to create a print in somebody's terminal whenever they're interacting with your log file? Or even better, if we do the 0i and change that to 5i instead, it's going to send all the output that we currently have to this non-existing printer. Because back in the days, they used to have this matrix printer next to you that we write all the log files there, so you have it in paper form. But you send it to something that doesn't exist. So the only way to get out of this is to exit your terminal, but all the commands that are happening is running in the back end, so you can't see that. This is fully functional. So if you started to poke around and push enter and stuff, you can imagine that it's going to put stuff that you're not going to see. And if you're going to be really, really annoying, we can have this mouse tracking feature. That's great if you want to interact with the system and know where the user puts its cursor. So like if you send this in, what's going to happen is whatever you move your mouse, it's going to report that on the screen. And if you click, it's going to execute whatever you put there. So that can be mildly annoying for people. And the only way here as well is to exit the terminal, because there's no way getting out of it. And I figured then, okay, that's cool. We're doing some DOS things here, but can we really like destroy stuff for people? Because some logs you can't interact with. And I found this one. And it seems so cute, not dangerous at all. repeat the preceding graphic character X amount of times. And in this case, so we will say, what happens if I take this emoji and I want it to be rendered, let's say, 10 times? Well, you're going to get 10 emojis coming out. But what happens if we add 1 billion of those? Because Unicode is not just 1 character, it's 5. So there's going to be a lot of stuff coming out. And from my own experience, don't run this in any kind of production, because it's going to destroy everything. You need to clean the log files, and you probably need to rebuild your Docker, because it's going to be there, and it's going to, whatever you access that, it's going to die. Because if you run this in Docker desktop, it's going to die every time. And it's not the only one. All these other terminals get bricked, and you can see the mobile one here can't even handle a small amount of it. It just crashes and dies. And then imagine what would happen if we would put that inside the server signature of our box, and then just ask for a Let's Encrypt certificate. I wonder how many scanner bots that's going to visit that site, look for whatever server version I'm running, and then I don't think their automation script is going to be that nice anymore. What were you saying, scary-looking kid? You got a question? All right, cool. No RC? No, I know. These are sad times. Actually, absolute darkness. But then light came in the shape or form of David Leadbeater, and his talk at Blue Hat in 2023, where he released not 1, but 6 remote code executions in terminals that are being commonly used by people. And David's work were inspired by some things from 2003 to 2008, where we were able to add like a new line into stuff, and it's called device control status string decross. He's way better at explaining it than I am, so I suggest you visit his GitHub repo, and on Sunday at DEF CON, visit his talk, where he's going to talk about some awesome stuff that he's been finding, because he's been putting shitloads of hours into how to break terminals. That's cool. I'm going to be there. The Strand boys is definitely going to be there, so that's going to be sweet. But even though he has this presentation when he showed it, I wanted a proof of concept that I would know how it worked. So I looked through his stuff, and I tried to figure out whatever he did inside this Kubernetes container that he had. And he eventually came up with this URL encoded line that looks like this, because you have all the escape characters in there. And I figured, okay, let's see what happens. So I started interacting with the log files coming out. And for this to work, you need to use iTerm2 version 17, which is the last version, not the newest one, because it's obviously being reported and fixed. Good on you, David. And what's going to happen if you take the log here and you browse it and you paste that payload in, press enter, boom, oops, cat's going to pop. That can be mildly annoying as well, because not everyone is really interested in math. So what does it work? You can see this here. It says $QM, and that's what it does. It kind of requests. It asks you what kind of color is currently being displayed on the screen, but it has the possibility to add something in there. This is where the genius thing starts. X03 is Control-C. The break kind of character. So what happens is that it's going to place that in. Then we're going to put in this case, the calculator popping one. And some new lines, obviously, because we like new lines. And then we're going to ask it to tell us whatever kind of color we had. But since we stated not colors, but commands, the result is going to be that it pops. It's great. And what happens if you're attached to a Docker container, it's going to exit out of it and kill the session. So sweet. Anyway, David was kind of the Mike Metzger for me when it comes to realizing that things were possible. Because before he did a backflip in competition, there was these rumors that you were able to do backflips on motocross, right? But after that, if you're not doing like a double thingy-majiggy with legs shaking stuff now, you suck. But he was the first that made it possible. So I'm like, maybe I can look at this too. So I started looking at the proprietary code in in Kitty, which is a widely adapted, really cool terminal, and they have this feature called file transfer over TTY. I'm like, nice. That's perfect. Maybe what happens if we look into it? And as you can see here, they had this variable called ID. It said test. And I realized that that bastard, that one, it rendered back like a reflection. I'm like, good stuff. I wonder what happens if we put a new line, calculate it there in another new line, and I fired it away inside Kitty. And the thing is that the first thing that happens is I'm going to ask you, do you want to connect to this and do some fine terms? And I said, no, but it popped. I'm like, fuck yeah. Awesome. I now got arbitrary command injection if you're using Kitty. And I can hear you sitting in the back saying, yeah, but you press no, right? What happens if you press yes? Well, it's the same. Yield strand. Boys, so that was fun as fuck. Oh, sorry, very fun. I didn't curse. And they're all happy, like, boom, this is exciting. And so answer the question that we started with, is it possible to execute commands in the victim's terminal? And the answer is actually yes, you are. But whose fault is it that we can do this? Because this is the conversation that has been going on for ages. Every 10 years, somebody looks at this bug class, and there's going to be somebody pointing fingers and say, no, that's not possible, this is the reason why. Because they blame it on the terminals, and the terminal blames it on the web apps, and back and forth. And then you have a bunch of old other people that's sitting in the back being really, really annoying and say, like, but everybody knows that everyone with a brain knows that you can't just cat a file or click on an email link. But that's simply not true. Because we need, as security professionals, we need to protect our users. And especially our shell users, because those are normally privileged kind of users. When we can do that simply by just sanitizing the input and escaping the output. That's kind of all what it takes. And if we don't do that, it's going to have consequences. And if you want to play around with this, I created this site called evil.terminalinjection.com, where I put a bunch of these different and really cool non-malicious codes, but all of them in there. You can use right-click view code and see what happens. And then you can run that inside your terminal to see what happens and what interacts. And if you do that, in some cases, it's all good. In some other cases, it's not at all. So it depends on what kind of service that you're using. And so you can play around with that. And I'm going to update that for the future and just put all this cool stuff that I find in there. I just haven't gotten to that yet. Sorry for that. And if you're black box testing this, and I realized the best way to actually get this to work is to simply try to generate 4 and 500 errors, because those are normally written to error debug log files. And access log files, it seems to be very well escaped, so that's cool. And the best thing that I figured that you can do this is to take, let's say you have a JSON query here, and you'll just append some Unicode to the back of it. And if you get a response coming back that says, internal error, this query is not supported, blah, 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 there's a very plausible chance that this actually entered into a log file. But if it comes back like this, it's been escaped properly. And it's very good for the developers because they did a good job there. But sometimes they escape it, but you can also then add some hex codes to it. So if you're adding the non-visible characters and that in, well, that might just come back non-escaped because they didn't expect the not/existing there. It's getting converted. Obviously, this is going to be prone to shitloads of false positives. And because sometimes you have stripped messages, developers are sneaky too. And sometimes you will get some data coming back that wasn't relevant, like we had in the beginning, right? But they are a big chance, like even though we have something like this, like a 400 error coming in, and 400 errors usually don't get logged, so you're going to want to have the real ones that smashes. And even though this seems to be everywhere, I don't want you to create a nuclei template and just go brr all over and spray this in hope of injecting stuff in people's log file. Not you. Because the way for you to verify that this actually works is that you have access to log files so you can see whatever goes on inside that system. Otherwise, it's just going to be like, well, you have this injection-ish. That's not going to work, especially if you're doing bounties. So to recap, people tend to forget. The old is the new, and there's way more to come in this area of research. And I'm just doing this talk to inspire all of you to start thinking about the consequences with not escaping stuff, and maybe get curious about playing around with it yourself, because there's way more stuff that's out there. I didn't have the room to put everything in here, but you can get fingerprinting coming back by just interacting with the log files that silently pings the DNS server, so you know when the incident response team are doing stuff. And like I said, it's everywhere. And I realized that when I was creating these nuclei templates to show that it actually worked, that it rendered inside nuclei as well. So it's very easy to take something that, you need to remember that something that used to be like meh today can easily turn into, oh crap, by tomorrow, when somebody adds a bunch load of creativity to it. Thank you. So let's go back to the beginning again. Your log files, you remember those? Do you still trust them? I'm STOK, and you'll find me at STOK on all the socials, and thank you for attending my talk.